It is time to execute the loop during which we will optimize the algorithm. The logic is the same as before, but this time, we will have a loop in the loop that goes over the batches during each epoch. As we explained earlier, for each epoch, we will go through several batches and will update the weights multiple times, instead of once per epoch. Let's get to work. For epoch counter in range max epochs, semicolons. The epoch counter is obviously the E from our TensorFlow introduction. The loss for each epoch is a simple average of the loss for each batch. At the beginning of the loop, we want to set the loss to 0. If you are afraid we will lose information, don't worry. All the information is backpropagated to the parameters at the end of each epoch. Okay, let cur epoch loss be equal to 0. It is time for the actual batching. Let's create a second loop inside the big one, which iterates over the training data. So, for batch counter in range batches number, semicolons. Now, we need inputs and targets for each batch. I'll declare input batch, target batch equal to MNIST, train, next batch of, batch size. When we imported the MNIST dataset, we imported a function that can load data one batch after the other. It is called next batch, and takes as argument the batch size. For now, that's all you must know. In the business case, we will create classes and functions in Python just to batch. But for now, let's use the readily available ones. Okay, the expression basically loads inputs and targets into the variables input batch and target batch. Right. Now, we use the session run operation, as that's where we optimize and calculate the loss. We do that in the familiar way. We run the optimization and minimize the loss by feeding it with inputs and targets. Or, batch loss equals ses.run of optimize and mean loss, comma, feed dict with input batch as inputs, and target batch as targets. That's the same piece of code we used in our TensorFlow introduction, but for batches. Cool. At the end of each iteration over the batches, we will increase the current epoch loss by the batch loss we just calculated. Let's summarize what this loop does. It loads 100 inputs and 100 targets into the variables input batch and target batch. Then, it optimizes the algorithm and calculates the loss, using these exact 100 samples. Then it records the loss for the iteration. At the next iteration, it loads the next 100 batches, and this is repeated until we go over the whole training dataset. That's the whole learning part. From here on, we will just validate and elaborate on early stopping. Okay, if we run this code, the current epoch loss will contain the sum of the losses over all batches. We can simply find the average loss over the batches by dividing the current loss by the number of batches. Notice this is done outside the batches loop, so inside bigger epoch loop only. That's because we calculate the epoch loss once the training over the batches has been completed. Alright, now the current epoch loss reflects the mean loss, as we wanted. But this mean loss is actually the training loss, right? What about the validation loss? As we know, at the end of every epoch, we validate. Since the optimization for this epoch is over, we can validate. Validation is done by forward propagating the whole validation dataset without optimizing. We simply forward propagate. Let's load in the input batch and target batch the validation samples. We will use the same function, next batch, but we will take it from the validation rather than the training dataset. The number of observations is equal to all the validation samples we have. When we forward propagate, we want to record the validation loss and the validation accuracy. This wouldn't be a problem for you if you have completed the exercises in the TensorFlow introduction section. We will record the validation loss and the validation accuracy in two different variables. They are equal to ses.run, mean underscore loss, comma, accuracy, comma, feed dict input batch as inputs, and target batch as targets. So, calculate the mean loss and the accuracy over the validation dataset and record them in the respective variables. Okay, finally, we want to print the result we've obtained. I won't go through the code thoroughly as it refers to formatting syntax in Python. We want 4 pieces of information: the epoch number, the training loss, the validation loss, and the validation accuracy. The current epoch number is contained in the epoch counter in the bigger loop. The training loss is contained in the cur epoch loss and is the average of the sum of the batch's losses. The validation loss was just completed through forward propagation and is contained in the variable called validation loss. Finally, the validation accuracy was calculated with the validation loss. The formatting is such that we have 3 digits after the loss for the losses and a percentage figure for the accuracy. Okay, are we done? One last detail needs to be addressed. We calculated the validation loss, but we did not set the early stopping mechanism related to it. I'll put a simple if, which breaks the loop when the validation loss is higher than the previous validation loss. We conclude with recording the validation loss in the prev validation loss variable. In this way, we will know when the validation loss starts increasing. Alright, let's go through the big loop. Each iteration from the big loop represents an epoch. At the beginning of each epoch, we set the current training loss to 0. Then we have a different loop for the batches. We iterate over a preset number of batches, all extracted from the training set. Essentially, we utilize the whole training set, but in batches. Therefore, we update the weights and biases as many times as there are batches. At each iteration, we calculate the sum of all batches. When the small loop has ended, we calculate the current epoch loss by dividing the sum of all batch losses by their number to obtain the current epoch loss. We forward propagate the whole validation dataset in a single batch through the optimized model, and we calculate the validation accuracy. Finally, we check if the validation loss is increasing. If not, we carry on with the next epoch. When we reach the maximum number of epochs, or the validation cost starts increasing, the training is over. Clear? Clear. Alright, that's the whole machine learning algorithm. In the next lecture, we will run the code and discuss the results. Thanks for watching.